Hi guys, happy Thursday, happy last day of April, and happy last day of e-learning for this week. Just think, next week we're literally into May and you're in your final weeks of 8th grade. That is crazy. I cannot handle that. Today we are looking at the exterior angle theorem, and then we are almost done with chapter 6, thank God, because it was the longest chapter in the world. So your objective for today, you are going to be using the exterior angle theorem, mainly with a triangle, to solve for unknown interior and exterior angles. So let's quickly recap some things from yesterday just to make sure that we're understanding and we're on the same page. So what do we know about the angles inside of a triangle? Inside meaning interior. Hopefully you're saying in your head, well, I know that the three angles add up to 180 degrees because they do. So all three interior angles add up to 180. So if I gave you a problem like this, and again, this is still just review, and I told you to solve for this unknown angle. You've got 30, you've got 50, and you've got x. You know that they all add up to 180 degrees, so you can actually write an equation to solve for that. So you've got 30 plus 50 plus x all equals 180. Then you can combine like terms. We know 30 plus 50 is 80, and then plus x are unknown equals 180. Subtract 80 from both sides. 180 minus 80 is just 100, so you got x equals 100. So if I gave you a problem like this, you could easily solve knowing that they all add up to 180. Now today, as we move on, we're going to be introducing the exterior angle of a triangle. When you get to geometry, you're going to start to see shapes like this that have like a random line coming off of there. That creates this outside exterior angle. Before I tell you what the exterior angle theorem is, let's see if you guys can derive it or figure it out based on the patterns that I show you. So take a look at this image. You've got 40 and 60, and then you've got 100 for your exterior angle. You've got 30 and 40, and then you've got 70 for your outside angle. You've got 50 and 70, and then you have 120 for your outside exterior angle. Can you figure out the pattern? Can you see what's kind of happening here? I'm hoping that this would be like if we were in class, you'd be like, okay, Miss Luann, I get it. If you add together these two angles, you add them, their sum is the exterior angle. So 40 plus 60 equals 100. I know 30 plus 40 equals 70. I know 50 plus 70 equals 120. So we can use this theorem, this rule, and kind of like the pattern to help us solve for unknown angles. So that's all we're looking at today, you guys. Pretty simple. So for your notes, your title will be Exterior Angle Theorem. There will probably be times when you want to pause the video to write some stuff down or take pictures of the slides. It might be a good idea. So here we go. Let's get started with just some vocabulary because believe it or not, there are a few new vocabulary words from yesterday and today that we need to make sure that we've covered. So we know that the inside angles in a triangle, like 1, 2, and 3 here, those are called interior angles because they're inside, interior. Now, more specifically, angles 1 and 2 are called remote interior angles. Remote interior angles. These two interiors do not touch this exterior angle. Okay, notice how 3, that's not highlighted because look, it's touching the outside angle. We know that 1 and 2 are remote interior angles. They do not touch your outside angle. I always think about like kind of like a remote pointing to them from this corner here. So if that helps you, great. But angles 1 and 2, those two interior angles, because they don't touch your outside one, are called remote interior angles. You'll see that on your assignment today. And then lastly, this outside angle is your exterior angle. Exterior, outside. All right, so here's what the theorem says, and this will probably be a good time that you want to pause your screen to write some things down. The exterior angle theorem says that the sum meaning addition, of the remote interior angles is equal to the exterior angle. Notice that the colors match. So remote interior angles, those are highlighted in orange here. And then the exterior angle is highlighted in green. We know that if we added together 1 and 2, it would be equal to the measure out here. Okay, we saw that in the pattern together too. We knew that when we added 40 and 60, it would equal the exterior angle. So that's all that the theorem says. Now we can use that to kind of identify unknown angle measures. So if I showed this to you, once it loads, and I asked you to solve for x, I wanted you to find this unknown angle. I know that if we add together our two remote interior angles, they would be equal to the exterior angle. So 40 plus 65 equals x, which will be our exterior angle. If you add those together, you get 105. So 105 is equal to x. It really is that simple, you guys. And then we can kind of reverse it a little bit. So now you're given the exterior and you've got 40, and then we're solving for one of our remote interior angles. But remember, if you just go back to setting up a very simple equation, 40 plus x equals 110, you can easily solve for it. So if we're solving this equation, this is actually just one step. We just need to subtract 40 on both sides, and then we get that x is equal to 70. And I know that that's true because 70 plus 40 is equal to 110. Now let's move forward and think more like, all right, let's start getting ready for ninth grade and put some variables and expressions in here, okay? Because this really is what you're going to be looking at next year. So if I asked you to solve for x, I know that with the theorem that we can do 2x plus 20, and that'll be equal to 4x. So let's set that up together. You've got 20 plus 2x is equal to 4x, based on the exterior angle theorem. Now, to solve for x, okay, here's what it looks like, and I just switched it around, that's okay. I see variables on both sides. I see 2x and I see 4x. So ask yourself which one is smaller so that we can move it to the other side. And I know that 2x is smaller, so I'm going to subtract that from both sides. And then I'll have 20 is equal to 2x. Divide both sides by 2, and you get that x is equal to 10. So using the exterior angle theorem here, we knew that we could add these two together and set it equal to your outside angle, and you use that strategy to solve for x. Let's try one more just to make sure that you've got it. All right, so take a look at this diagram. I'm asking you two things. I'm asking you, number one, to solve for x. I'm also asking you to find the actual measure of each angle. If you were to tell me that this angle is 10x minus 2, that's the measure of it, I'm going to say, I don't think so. It's going to be like 70 degrees, 40 degrees. So we're going to have to solve for x and then plug that back in to find the actual angle measure. So here we go. Let's use our understanding of the exterior angle theorem to make this happen. So I know that if I add together x and 4x plus 18, that is all going to be equal to my exterior angle, which is just 10x minus 2. So notice how easy it was for me to set up my equation. You just add these two together and set it equal to your outside angle. Then we can combine like terms. I know 1x plus 4x gives me 5x. And now I've got 5x plus 18 equals 10x minus 2. This is just variables on both sides. So ask yourself, what's smaller, 5x or 10x? And hopefully in your head you're saying, so man, it is 5x because that's what it is. So that means we'll subtract 5x from both sides. These will cancel out and you'll be left with 18 equals 5x minus 2. Then to isolate 5x, I need to move this minus 2 to the other side using inverse operations. So the inverse of minus 2 is plus 2. Once I add 18 and 2, I've got 20 equals 5x. Divide both sides by 5, and you get that x is equal to 4. So a lot of work, but the exterior angle theorem helps us to set up the equation, and then your knowledge of solving equations helps you solve for x, and we know that x is 4. Now we can go do the more complicated part, but really not that complicated because you guys are awesome at solving equations. We have to find each angle measure here. We know that x is equal to 4 because we just solved for that on the other slide. So right here, you can actually already figure out what this angle measure is. If it's just x, then that angle measure is just going to be 4. But we need to figure out, all right, what is this angle measure and what is this angle measure? To do that, all you need to do, you guys, is just take out your x and substitute in 4, okay? Because that's what you solve for, okay? So it looks like right here. When you simplify, 4 times 4 gives me 16. 16 plus 18 gives me a sum of 34. So I know that this top angle here is going to be 34 degrees. And I'll try and write that in as neatly as possible. Then for my last angle outside, again, we're just going to be taking out the x and we're going to be plugging in 4 so that we can simplify. So you got 10x minus 2, take out the x and plug in a 4, and you got 40 minus 2, which is 38. So this outside angle, the exterior angle, measures 38 degrees. You also know that that's correct because if you add 34 and 4, that gets you to 38, which is your exterior angle. So, ladies and gentlemen, as you move forward and you're going to get your assignment done for today, just remember that when you add the two remote interior angles here, they always equal your exterior angle. That's going to guide you as you go on. All right, so that's it for today. Your assignment is the exterior angle theorem Google form, and it looks like this. I'm going to show you on screen. So it is pretty quick and easy. Most of the work, a lot of the questions are just about vocab, just to make sure you have that down, and then you'll have to solve for a few. So make sure you have your calculator and you are ready to go. Please get that submitted by 11:59, and please, 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 please use your first and last name. All right, enjoy your day off tomorrow. See you later. Miss you.